Well, here we are. And what a better day to begin a chapter on matter and energy when it's so cold outside. If you go outside right now, you will feel cold because your body is losing energy from your hot body to the colder air because heat always travels from the hot body to the colder body. So it's an excellent example of what we are going to be talking about. And you are made out of matter. So talking about that, this is are the concepts that we're going to discuss in this chapter. We're going to see what matter, atoms, and molecules are. We're going to classify them as solid, liquid, or gas, and we also are going to classify them as elements, compounds, or mixtures. And then once we see how we can classify them, then we can start looking at them as scientists, and we're going to be thinking about physical and chemical properties and the changes that matter suffers that can be physical or chemical. And then we're going to see that matter can never be created or destroyed. It can only be transformed. It's always conserved. We're going to see that there's matter is intimately related with energy. They go hand on hand, and we're going to see what different type of energies we have. And we're going to see how we can convert between type of energies to other type of energies. The same way we convert from pounds to kilograms, the energy also has different units that we are going to need to convert to. And in terms of energy, we can talk about exothermic and endothermic, where exothermic is a reaction or a process that releases energy, while endothermic is a reaction or a process that consumes energy. And energy, specifically the energy in the form of heat, is very related to temperature because that's how we measure it. And it's related to what the matter is doing. So we're gonna see how we can relate the scale of Fahrenheit, Celsius, and Kelvin to one another. And once we do that, then we're gonna have all the tools that we need to be able to talk about the rate of energy, how energy relates to the temperature change, and the capacity that matter has to absorb heat and change temperature at the same time. And we are going to call this the heat capacity. And once we learn all those concepts, then we're going to bring it down to mathematically be able to measure and calculate and predict them. So it's a very interesting chapter. This is one of those chapters that allows me to see, oh, I understand why this is happening now. And it makes chemistry very real. So let's begin at the beginning, like always. So let's start with the first objective, define matter, atoms, and molecules. So let's start with matter. What is matter? Well, matter is everything around you. Like we said on chapter 1, as you look around you, everything is matter, with the exception probably of light. Because for something to be matter, it has to be able to fill those two requirements. It has to have mass, and it has to take space, or it has to have volume. For example, if I take a quarter and I put it on my scale, I'm gonna see that it weighs around 5.8 grams. And I can measure the circumference, I can measure the height or how thick it is, and I can calculate the space it takes. And I know it takes space because if I throw it on water, the water get displaced because the quarter is taking the space where the water used to be. So if you can find something that doesn't have mass or doesn't take space, you probably are talking about light, which is the only thing that comes to mind that is not classified as matter per se. Another way of seeing it from a chemist's point of view is we have the periodic table, and everything, as far as we know, all matter in this universe is made out of this element. As far as we know, we can find something later that we haven't discovered yet. So if it's made out of these elements, it's matter, as simple as that. So H2O, matter. Why? Because it's made out of hydrogen and oxygen. Nitrogen, the oxygen that we breathe, all those are matters because they are made out of elements from the periodic table. What about atoms? Well, atoms are going to be the smallest you can go. And you can represent it like this. So, for example, if I have a piece of matter, let's say I have like a block of matter, if I break it apart, then I will end up with something like this, more or less. And if I break it apart, then I end up with something like this, more or less. And if I break it, I end up with something like this, more or less. And I can continue breaking it and breaking it and breaking it. And if I do that millions of times, assuming that I can see what I have, I probably have something. When I magnify, if I can visualize it and imagine it, I probably end up with a piece really, really small like that. And if I break it again and it breaks apart, into other things, then I basically saying I broke it down to the point where I destroy it. So whenever I get to the point before I destroy it, that is always the same as before, then that's what I'm going to call an atom. It's the smallest particle I can go where I have the same thing. For example, if I take a block of gold and I break it down to the smallest I can go, and I can still say, yeah, that melts at the same temperature as gold, it has the same color as gold. If I break it once more and it just break into smallest pieces that have nothing to do with gold, then before I broke it, that was the atom. The smaller you can go, that still have all the properties of the matter that you were looking at. So that's what the atom is, the smallest you can go. What about molecules? Well, molecules are going to be when you put atoms together. So let's say that I have an atom of a substance or some type of matter, and I put it together with another one, that's a molecule. So this will be an atom, this will be a molecule. What about something like this? This will be an atom, and this will be a molecule. So a molecule is nothing more that when you have atoms that are connected together, more than one. What about if I have something like this? What would that be? So this is an atom, this is a molecule, this is a molecule, and this is also a molecule. So a molecule is nothing more than two or more atoms joined together. However, if the atoms happens to be all of the same, then and they're bonded together, then we call those molecular elements. So an atom by itself represents an element, and it's an atom. If you have two of the same or more joined together, they are molecules, but they are molecular elements. If they happen to be joined together different, then they are molecular compound because they're compounded, they're different. And we're going to talk more about that before. So the main point here is molecules are going to need more than one element combined together, bonded together. So with that, I will say that we have covered what matter is. The atom is the smallest you can go, and the molecule is when you start combining atoms of the same or different. If they are atoms of the same combined, then those are going to be molecular elements. If they happen to be a difference, then they're going to be molecular compounds. But both of them are molecules because they have more than one element combined together. Now let's start classifying. Now that we know what matter is, let's start classifying. So what is a solid? What is a liquid? And what is a gas? All this indicates how these atoms or particles are joined, are coming together. For example, if I have atoms of one element and they are very tight together, so what we're doing here is trying to visualize matter as we know it, like solid, liquid, and gas at the atomic level. So if they're very joined together, that's going to be a solid. If they happen to be together but not so together as before, and they are a little bit more disorganized, then that's what we're going to call a liquid. And if they happen to be very far apart from each other, that's what we're going to call a gas. These particles are always moving. If they happen to be a solid, they're not really moving, but they are vibrating. They are moving on place, they are vibrating, and they're very tight together. If they happen to be on a liquid, they're moving randomly, but they are kind of following each other. That's when you have a liquid on a container and you move the container, you see like the liquid kind of flowing, but staying together. And when you have a gas, they're moving like crazy, away from each other. They may collide every so often, but they always moving randomly. It doesn't matter what state, solid, liquid, or gas, but they're moving everywhere and very fast. And that's what we call a gas. And that's going to determine if you have any of these phases on your hands, that's going to determine how hot they feel to you because of the amount of movement that they had. So we're going to see how the temperature is going to relate to the movement of the particles. We're going to see even that's how a thermometer works because of the movement of the particles. So let's have our first daily work 3.1. If you have a container and you have matter on it, and if you're able to look at it at the atomic level, and you see something like this, let me change color so you can see it better. And you see something like this at the atomic level, assuming that you can see it, Will this be a liquid or a solid? Compare probably to this. So we're going to call this A, we're going to call this B, and B is going to be something like this. So which one is A? Solid, liquid, or gas? Which one is B? Solid, liquid, or gas? That's daily word 3.1. And with that, we can say that we can classify matter as either solid, liquid, or gas, and it all depends on how close together those particles are. Now let's talk about something else before we go. Let's say I have a container like this, and I throw something in there, and the particles do something like this. I throw that in there, and the particles do something like this. Will that be a solid, liquid, or gas? And the answer will be, that gotta be a gas because it went away from each other as much as possible, and they are just taking all the space. So the gas tends to take all the space. So in theory, if I open a soda drink right now, you're gonna hear the hissing of the gas coming out. And within months, those molecules that came out of my soda drink, within months, I can probably find them all the way across the world because they will travel and take us all the space they can take. So what about this one? This is another type of classification. So the first classification was matter can be classified solid, liquid, or gas. So this one goes a little bit more on depth. So on this case, we're gonna start with elements, compounds, or mixtures. What is an element? An element is, assuming, and this is the analogy I like to do. If you have a container, and the container is full of particles, it could be atoms, it could be molecules. If the container is full of particles, and all of them happen to be the same, and let's say that you take your hand and you put it in there and you grab one of those, and you have your eyes closed and you go and grab another one and grab another one, would there be a possibility that you will get something different at one time? Or would you be getting always the same? And the answer is, with this drawing, you will always be getting the same thing. So when you have a sample and every single particle on the sample is the same, we're gonna call this a substance. And if that substance happens to be atoms of the same, then the substance that you're dealing with is an element. But let's say also that they're bonded together. So now they are not atoms anymore, right? Now they are molecules. But these are molecules that the atoms that are bonded together are the same. And what did we say about that? We said that those are called molecular elements. So they still elements. They could be atomic elements, where it's just the atom by itself, or they could be molecular. Let me do this again, sorry. Or they could be molecular elements, where you have the same type of atom bonded together. But what happens is what you have is not the same. What happens if what you have is something like this? First thing, back to the analogy. If you grab one of those and grab one of and keep grabbing and bring it out, is there a possibility that you will ever get something different? And the answer is no. You always get the same type of particles. So we're still dealing with a substance because all the particles are the same. But now, what you're pulling out now are compounds. So one way to classify matter is by seeing if the matter is a substance, which is going to be elements and compounds, or a mixture. So the analogy for the substance, which could be an element or a compound, is the one I just told you. All the particles that you can bring out are the same type of particle. So what would be a mixture then? A mixture, on the other hand, so focusing on the mixture now, a mixture, on the other hand, would be something like this. So, back to the analogy. As you pull things out of this container, is there a possibility that you may pull out something different on one of your pulls? And the answer is yes, because now you have this type of particle, but you also have this particle and this particle. Now you have three different things in there, therefore it's a mixture. So a substance is where all the particles that make the sample are the same. It could be an element or it could be a compound, while a mixture, not all the particles are the same. So let's bring this to the macroscopic level, at the level where we can see. If you have something like this, and I'm gonna say that this is a grilled cheese sandwich, if you have something like that and you break it apart, can you get different things? Yeah, you can get the bread and you can get the cheese, so this is a mixture. What about if I have a glass of water? If I bring a drop out, would that be H2O? If I bring half of the material out, would that be H2O? Yes, and every time you pull everything out, it's gonna be H2O. So this is a substance which happens to be not an element, but a compound, because it have two different elements, hydrogen and oxygen. So that's how we classify something from between being a substance, which is an element or a compound, or being a mixture. But I can tell you more now about mixtures. So let's talk more about mixtures, because mixtures can be subclassified. So mixtures can be homogeneous mixtures or heterogeneous mixtures, or heterogeneous or homogeneous. Either way is acceptable. So those two will be the classification of mixtures. So imagine that you have in your hand a jug of milk. So we know from the TV, we know that that milk contains fat. That's what sometimes you buy 2%, so only 2% fat, but it contains fat. It definitely contains water. We know it's good for you because it contains vitamin D. So it's a mixture, right? It has more than one thing. But when you look at milk, if I ask you to describe milk, you say milk is a white liquid. So you only see one thing. So mixtures in which you can only visualize one thing, in the case of milk, a white liquid, but we know that it contains more than one thing, like water, fat, vitamin D, and so on, then this is what we call a homogeneous mixture. So let me fix that up. So this is what we call a homogeneous mixture. What about heterogeneous mixtures? Heterogeneous mixtures are going to be the ones where you can see with your naked eyes, you can see more than one thing. First example, what would it be? One of our first examples could be this one, right? So we can have our sandwich. Do we see more than one thing in our sandwich? Yes. We see the bread and we see the cheese. So we can easily identify that it's a mixture because we can actually see more than one thing on it. If I showed you, for example, a white liquid, would you drink it thinking that is milk? I wouldn't. What if it's a white paint or something like that? So when you cannot see what it's made of, but you happen to know that it's a mixture, then it's a homogeneous mixture. When you can actually see more than one component, then it's a heterogeneous mixture. So let's do another daily work. So daily work 3.2. So if I happen to have something like this, would that be a substance or a mixture? B. What about now? Would that be a substance or a mixture? What about now? substance or mixture. What about now? Substance or mixture. So once more, A that was A. Then we did B. Then we did C. And then we did D. So that's your daily work 3.2. And with that, we're gonna call these three objectives as completed. Make sure that you watch all the tutorial videos in there. If this doesn't do it for you, email me. I can probably put something else together. And when you go into Alex and you start practicing, you will definitely get it. So as of now, we discussed what matter, atoms, and molecules are. We classify matter in terms of being solid, liquid, or gas, the state or the phase. And we also classify it as substance or mixture, knowing that the substance are elements or compounds, and that the mixtures can be either homogeneous or heterogeneous mixtures. So let's leave it there. Next time we meet, we will go into 3B. So let me know if you have any questions, please. Thank you. Stay warm and safe.